Our h is all that's left on this side, and we have a over w. It won't simplify any further. If it bothers you to have our equals on the right-hand side, you can switch them. H equals a over w. It does not matter to me how you do it. Equals h is the same thing as h equals. But we did that by dividing both sides by w. So then let's look at B. Let's look at this next one. What do we do to solve for w? I want him by himself. You can divide here. That's a fine option. It's not the easiest way, but it's definitely doable. Subtract 2h is probably going to be your easier option. If you're not sure where to start on these, when we simplify stuff, we do PEMDAS, right? Like if we're not crossing an equal side, we start at the top and go this way down. This is simplifying. If we're not sure where to start when solving, an excellent strategy is start from the bottom and go up. So deal with things that are being added or subtracted to what we're solving for. Then do things that are being multiplied and divided. So if we're solving and you're not sure where to start with things that are being added and subtracted to. Okay, so I'm not saying it's the only option. There are lots and lots and lots of different paths through. But if we're not sure where to start, because I had a whole lot of on that one, start with things that are being added and subtracted to whatever your target is. So what is being added to my W? What's being added against the W? More than just 2. What is being added? 2h. So we can subtract the 2h from both sides. Oh, we have what on the left side? We have what on the left side? Yeah. What did we forget? P minus 2h equals 2w. Still trying to get that w by itself. Now what do I do? Divide by 2. So we wind up with either this super gross fraction of p minus 2h over 2. That is a valid way to write it. I'm going to switch it over on this side so we have our w equals. Does anyone see anything here we could simplify if we broke it apart? Okay, then let's break it apart. If I uncombine my fractions, p over 2 minus 2h over 2. To be able to add and subtract fractions together, they have to have that common denominator, right? So if I'm uncommoning that denominator, now do we see something we could simplify? Look over here. We can't what? You're right, we can't combine them together. Think simplify. I have p over 2 minus 2h over 2. The 2's. 2 over 2, those guys will cancel out. So another way we could write this is that our w equals p over 2 minus h. I'm going to pull back one of those words we've used a hot minute. This expression is equivalent to this expression. They mean the same thing. No matter what h is, no matter what p is, those two expressions mean the same thing. Let's look at C. We're trying to solve for h on C. So solve for h means I want to have an h equals. So what do we need to do? I want to solve for h. We're going to need to divide because what is being multiplied against my h? Pi r squared. Pi is just a number, a gross number, but a number. And we can do this division all in one chunk. We don't have to do it in two chunks. So we're going to divide both sides by pi r squared. That means these guys and these guys are going to cancel out. What's up? Did you say we've lost you or that you lost the game that we're playing that we're not supposed to be playing while we're doing stuff? Uh-huh. Yeah, that's because we lost, right? You lost the game. Millennial thing. So again, we can just make it switch sides. H equals is the same thing as equals H. So this is V over pi r squared. These equations are all actual formulas. For that one, yeah. Because this first one, this is the area of a rectangle, height times width. So if all we had was our area and our width, this would be how we could solve for our height. Height equals the area divided by width. This one is the perimeter of a rectangle. Twice the width plus twice the height gives us around the edge, like we're building a fence. This one is the volume of a cylinder. We're just solving for height. So it's pulling up our old geometry formulas and using them in our algebra stuff. Someone's got their geometry in my algebra. All right, so let's look at D and E. So there's an important piece in D that you may or may not have seen before. Not you. Because I know you've seen it because you literally just said it. There's a thing in here that we've never seen, unless we use photomath on the regular. The little guy on the bottom. The little, like, it looks like it's saying V-O-T. It's a 0. This is often read as V-naught, N-A-U-G-H-T. Naught. It means 0. It means at the start. It's a velocity kind of thing. So if you did physics, you may have seen that. It's a velocity thing, but we read that as V naught or V sub 0. No, but it shows up in one of the formulas that the state prints on the final, and I don't like this to be like they give us formulas. I promise I will tell you when we get to the point of it. Okay, but I like to introduce it a little earlier, and this is the only time they use a sub number in our book, but they put one in one of the formulas on the final in the spring. So I like to point it out when we have it so that we can see it. It doesn't mean anything different. How many questions about the V naught? None. But if we want to use the formula, I don't want it to throw us off thinking we need to put something there. Okay? Treat it just like it's an X or a V or whatever. It's just a way of saying, like, if you ever looked at, like, totally none of us ever have looked at photomath. No. Where they do that X with the little 1 and the X with the little 2. I think, no. It's the same kind of thing. It's just V0. So whenever, like, if you look on photomath, they're going to often write it as X sub 1 and X sub 2. And these are your solutions. Okay, whichever one you're using now. It still does this because I still see it when people cheat on homework. Y'all, the collective generations cheating photo software. Just saying, the collective generations. the collective generation's proclivity for software, they still do this. So the little number at the bottom is just an indicator. It is not anything important. So either way, we're still going to try and solve this thing for A. The V is unimportant when it comes to this process. So we're going to solve for A. I want A all by itself. So what do we need to do to get that A by himself? Eventually, we will need to divide, but we don't want to do that right here. It's going to make things super gross. I'm going to get rid of that pink bubble right there. Yeah, so I'm just putting this as the label here. So I want to get the A by itself. And I don't really think, I don't feel like dividing right here first because we have a whole lot of going on. So let's get rid of some of this stuff. So let's start with subtracting. We need to subtract this whole chunker because that is being added to my chunk that has an A. And I want A by itself. So let's subtract our V naught T from both sides. V naught T. V naught T. Not naughty. So what we have on the left-hand side right now is H minus V naught T. And everything left on the right-hand side is our 1/2 A T squared. I still want to get my A by itself. What should we do next? I have a couple options here. And just about all the things I see are about equally easy. What's up? A is not being squared. Only the T is being squared.
Yeah. Wait. So you divide because it's been multiplied.
Yeah. So my A and T are being multiplied together. So we're going to divide. Divide by what? Are we dividing by?
1/2.
Well, I want to keep the A.
Oh, 1/2.
So we can divide by our 1/2. That's fine. What else do we need to divide by that's being multiplied against my A? T squared. Not the easiest to divide by a fraction. Not wrong, but it's not the easiest. It's going to make our answer super gross to have this fraction within a fraction. Did anyone deal with the fraction in a different way? I know you didn't. So 0.5. So divide by 0.5. Definitely similar. Did anybody deal with our 1/2 with multiplication? How would we deal with this with multiplication? Get rid of the 1/2. Multiply by what?
2.
By 2. So instead of, I'm going to do this instead of dividing by the 1/2, I'm still going to divide by my T squared. What's up? So I'm going to bring it to the right now, just because I'm running out of space. My H minus V naught T over T squared is 1/2 A. And we're almost there. But to get rid of that 1/2, it's sometimes easiest to just multiply by our denominator. That's going to cause my denominator to cancel out. So if you have a fraction and we go, ew, and we don't want to deal with fractions, multiply by your denominator to get rid of it. So our A is really going to equal 2 times, and we have to have 2 times the whole thing, so we're going to put it in parentheses. H minus V naught T over t squared. I'd be 100% okay with that answer. If you decide to distribute out the 2, that is also okay. But having a fraction in your denominator is not at all pleasant. And this is a physics equation. It's a velocity and acceleration kind of dealio. Yeah. We're not going to play with physics equations all that much. Let's look at E. E looks super scary. It looks super scary because we have x times y. I've got fractions with x's and y's in them, and it's a whole lot of. What do we do to get rid of fractions? Multiply by that.
X, y plus 8.
Why? The question why, not the letter y.
Oh, because you're trying to get rid of the...
Because I'm trying to get rid of the fraction. So if we multiply both sides by our denominator, it's going to cancel out. So if I multiply this left-hand side by 3xy plus 8, and I multiply my right side by 3xy plus 8, on the left-hand side, they cancel out. So we have 2xy minus 7, 3xy plus 8. Okay, already less gross because it's not fractiony anymore. We are solving for y. It's because I whited half my stuff out so that I could do that there. I wrote it over here. We're solving for y. So what should we do? I've got y's on both sides here.
2 or 3, whichever side you want, right?
So if we don't like negatives, move the smaller one. Whichever one's smaller will give you fewer negatives. I'm going to take the whole 2xy chunk and subtract it on both sides. Minus 2xy. Because I want to get those y's together. Because I don't want y's on both sides. So I have on the left-hand side, I have a minus 7. On the right-hand side, I have 3xy minus 2xy. So what do we have left? Just 1xy. If you want to write the 1, you absolutely can. Totally fine. Plus 8. Subtract 8 on both sides. Good. So I'm going to bring it up over here. So negative 7 minus 8 gives me what? Negative 15 equals xy. Still trying to solve for this y. It's been multiplied, so what do we do to get rid of it? Divide by x. So here my x's cancel out. We're left with y equals minus 15 over x. And they're gross. Literal equations, meaning literally made of letters, like literature, they look super duper gross when we're done. The way we can tell that we're done is if we have whatever we're being asked to solve for all by itself on one side. So I've got my a all by itself over here, so we finished solving for a. On this one, we had to solve for y, and my y is all by itself over here, so we're done. So they look super gross sometimes. But we can deal with them. Y'all dealt with a physics equation and a rational function that is all kinds of weird. Technically an inverse variation. Okay, so we approach them in the same ways. we deal with things that are being added or subtracted, then things that are being multiplied, and go for any kind of weird stuff at the end. So, homework 2-3, which is I believe the only homework for this week, is based off of this. It's using equations and formulas, solving for letters, so there's going to be some literal things in there. And you guys have 10 minutes left where you can start working on this. So homework 2-3 is the next homework in this chapter. And I think it's the only homework I gave you this week. In Unit 8, we do have more homework than this. It's not going to be just one a week, but for now, it's still just one. What's up?